In this session, we will learn about inner join. The Cartesian join you may or may not use regularly, but inner join and left outer join are the most common joins which we use every day. So before jumping into the SQL code, I would like to show you set theory for joins. So the inner join, it brings the records which are common between both tables. Only those records. It will not consider any other records. And outer join, it will consider whole the records from both tables. So outer join means full outer join. So in the outer join we have again I need to mention here full outer join, but yeah, it's okay. So this please consider this as a full outer. So in the full outer it will consider both tables. All records will come like a union, but there is a little bit difference between the union and full outer. We'll see that in the next session. So the left outer join will bring all the records from left table, and whatever the common records we have, those records will come, but it will not consider records which are not common between left and right table. Similarly, right outer is reverse to the left outer join. It will bring all the records from right table and common records from left table, and it will ignore which are not common in the right table, left table. So basically left outer, right outer both are same, but left outer will consider left table on priority, and right outer join consider right table on the priority. Okay, let's see how it works in SQL. So we'll start with inner join, then we'll go to left outer, right outer and full outer. If you understand inner join perfectly, then left outer outer joins are easy to understand. So please pay more attention for inner join. Understanding tables and their data is more important when you are working with inner joins, any joins. So that's why I kept the tables on the right side for our reference. So what we know from previous session is Cartesian product. Select star from student and alias as S, comma, course C. So what we know this, and it will give 63 records, it multiplication of student and course. So this is Cartesian product. Okay, in the Cartesian product we have a course ID in both tables, course from the student and ID from course table. So let's put one condition where S dot course is equal to C dot ID. So because in my from statement I have two tables, student and course. So in the where condition I can access both tables, course and student and course table. So if I put some condition like this, yes, from student table course column should be equal to course in the course table ID column. Course from student table, ID from course table should be equal. So if I execute this, you see the record count is reduced from 63 to 8 records. So what you observe here is the course ID, these two columns, course and ID columns, are same, exactly same. And if the first three columns are from student table and last four columns are from course table. In student table actually we have 1, 2, 3, 4, 5, 6, 7, 8, 9 records. But we have only 8 records here. The one record which is missing is, I think, 1, 1, 2, okay, 9 is missing. Yeah, here you can see 9 on the student table. That 9 is missing because 9, there is no course ID for the ninth record. So when the null value is there, it don't know how to join with the other table. That's why if null value is exist, then it will not bring any records. So inner join need common records, right? So each course, however, any student can register courses which exist in course table. That's a basic, right? So course table will have all courses, and student records will student table will have few records, maybe few courses. Some people may not register for all courses. All students may not register for all courses. So we miss some courses like C3 here. Yeah, C3 is not here, student table. So C3 is there in course table, but it didn't bring the C3 from the course table because C3 not exist in student table. So the records what we see here are common between student and course table on the column of course and ID. Okay. Like that, we can add more conditions, and price greater than 300. So it will bring. So this where condition is working on particular column price, and this where condition is looking for the combination of records. Okay. So this is called a, if you remove this, you can keep that or remove that, it doesn't matter. So what we know is this is Cartesian product, but when you add a where condition on two columns, that becomes inner join. So this is nothing but a inner join, but the syntax is implicit syntax. So we need to write explicit syntax, otherwise this is like, suddenly if you see this code, you may understand, okay, this is a cross join, but it's not. It's actually inner join, because in the where condition we have two cases and you may not identify where the join condition is there. That's why it's always good practice to use explicit syntax for the joins, so it's easy to understand and errors will not appear. So to make the explicit syntax, it's simple. Like cross join, we put inner join here, and instead of where we use on, and rest of the conditions will be in the where. So if I run, so see the previous result. These are the previous results, right? So 5 rows we got, and if I run this code, we get the same exactly same results. Okay, so this is called explicit syntax, and always maintain explicit syntax, not implicit syntax. So in the inner join, if you remove this inner and keep only just join, still it works like a inner join, because inner join is the most important join variant out of all joins what we discussed and we're going to discuss. That is the reason join keyword is the default keyword for inner joins. So when you use just join, it will work like an inner join. It's not required to keep always star here. I can add columns, course. So I got the courses, and I can add more ID. Okay, I got column ambiguous, because from which table you want to take the ID, because course I have only one column with course in my result set, but I have two columns with ID. So here you can see ID in the student ID and ID in the course ID. So which ID you want? So I want student ID. Then use the table alias. And here if you observe, I selected course from student table, ID from student table, and I am not selecting anything from the course table. So it's not required to use columns in projection list for both tables. You can select columns from either left table or right table or both tables. Okay, so let's remove this. Okay, if someone asks you a question like this, what are all the courses registered by students? I want only the courses which are registered by students, and I don't want the course IDs or course names which are not registered. Okay, so we know this inner join will filter out records which are not common between course and student, if we consider course and student for joining. So if the course is exist between course and student, then that course is registered by students, right? So in that way, select c.id from course C join. So always use inner join. It's recommended. You can use join, but it's recommended to use inner join, so it's easy to understand for someone. Student is on c.id is equal to s.course, right? So if I run this, I got the courses which are registered by students, and if you see, almost we got 8 records, because student also have 8 records and 9th record is null, so null is ignored and we got 8 records. But we have duplicates, C4 2 times, C5 2 times, because C4 and C5 are registered by students 2 times. 2 students registered for C4 and C5. So we know how to eliminate duplicates, right? Distinct C1 2 4 5 6 7. 3 is not registered by any of the students. So this code answer your question. The list of courses which are registered by students. List of courses registered by students, and we brought the list of courses by using distinct keyword. So distinct is more common keyword we use in joins, because when you join 2 tables, you may get duplicates based on the projection list what you are selecting. If you select all, then you may not see the duplicates, but if you select 1 or 2 columns, then you may see duplicates. That is most common in joins, because we are selecting particular columns. That's why the duplicates are appearing. That's 100% fine. But to avoid duplicates in the result set, use distinct, and it is more common in joins. Okay, so as of now what we are doing is we are selecting only 2 tables. We are joining on 2 tables, but we can join more than 2 tables. So let's add another join instructor I on s.id is equal to I.id. We'll remove this part and So we joined 3 tables. Let's understand how this join executed and how this result prepared. So what we know is, so let's ignore the third join and let's run this first join. Okay, I got results of C1, 2, 4. Okay, this is the same previous result. So out of this previous result, what I am doing in the third join is instructor I added for the third join, and I am joining on the instructor ID with the student ID. So what I am expecting, who are the instructors registered as students? So the student ID should be equal to the instructor ID. So here student ID, so this is the student table. So I have 1425. Okay, let me order by s.id. Okay, I have 1, 2, 3, 4, 5, 6. These are the students. And if you see here in the instructor, I have 2, 4 from that list, and yeah, 2, 4, that's all. I don't have any other values in the instructor, 7, 8, 9, which are not the part of this. So I have only 2 and 4. So let's add this join. So you know, order by should be the last one. So we need to add join here. Okay, now if you see the result, 2 and 4, and from the instructor table also I got only 2 and 4, but 4 is there 2 times because it's based on the join. Like we may have 2 registrations for the core 4, that's why 2 records. So what I'm intent to say is, join will execute first this condition, and the result set of this condition will apply as a table on this join condition on the instructor table. So that's how the multi-join will work. Like we have 3 tables now. You can, like that you can add more tables, but it's going to be more complicated. So make sure when you are doing that. So you can join on same table itself. So for example, select star from course C, inner join, on, okay, I'll put C1 dot price is equal to C2 dot price. So this is C1, this is C2. If you observe here, price column will be same for all records, and it's not required to use equal to always. You can use any other compare operators, but when you use other compare operators, you will see the result entirely different. So here the first price column is always smaller than the right price column. So in the first price, the highest value in our table is 500. So in the first column you will never see the 500, because less than 500 we don't have anything greater than 500. That's why the 500 is missing here. So you can use any other compare operators in the inner join.